Hi guys, in this video we're going to maybe review hopefully what you've already given a go for another practice quadratic regression problem. So this is very important. We probably in the future going to be doing, if we have not already done linear ones, linear regressions and exponential regressions. So what you learn here you'll also be able to apply for different types of functions and probably use it on the final exam as well. So take a look at this already if you have not. And we're going to have some data below that you have a relationship between the amount of fertilizer used in 18 tracts of land and the crop that it's yielded. So before we get going here, in other words, so for a certain amount of fertilizer X, and I'm going to call that L1, it's going to yield an output Y of bushels of crop. And we'll call that L2 just because I'm going to match up. And I've kind of pre-loaded the calculator to make the video a little bit shorter here. So um, first thing first, let's take a look at the data. Remember, in real life, which is kind of where we're going towards now with word problems and contextualizing problems in a real life format, um, the data is not going to be perfect all the time. So take a look at the fertilizers and the yield for every input. To have a function, you need one output. And the question for part A is before we get going or even started, do you have a function or not? And they're giving you the answer. Why is there not a function here? And as you can pause the video and take a look for a second. But as you're looking for every input, there can only be one output. So for one input of zero, by the definition of a function, you should only have one output of a 4. And here there's an output of 6 as well. So just that one case blows up the definition of a function, meaning just one time if that occurs, the whole bit of information, your equation is really, you don't have a function. But a lot of times, what we'll do in mathematics, because our data sometimes will overlap, case in point here, is we'll make some exceptions and say, okay, well, that's not a function, but if we kind of say, or would like to find a function that does abide by that rule that's close to this information, not perfect, but a best guess or a best approximation of a function that would adhere to this, that's when we use a regression. And the question is always, what type of regression should we be using? Does your data go like this in a straight line? Does it look like, no, we haven't got to exponentials yet. And if we have, just disregard that remark. But that's an exponential form. Does it look like this? This is linear. Or does it look something parabolic, concave up or something like that, so to speak? So depending on what your inputs and outputs in your function looks like is usually a good place to start as far as what type of function to get. Now, because we're practicing quadratic regressions, you're already going to know that we're going to be practicing the quadratic model, which means you're going to get a function that is either represented by something that goes up and comes down or that goes down and comes up. Now, we can look at this stuff and notice your values go up here for the outputs. So in other words, they hike up and then they start coming back down. Once they hit some max up here, some vertex, looks like the values might be retreating and coming back down. So before we even get going, we can say that a quadratic model is better because the values don't continue to go one direction or they don't start off slow and go up. And then other exponential would be starting going down fast and then kind of leveling out. But again, this would also be an exponential. And that's just kind of a best guess as a way to eyeball it. Or again, we're guesstimating here. We are making an estimation based on data that's not a real function. But because sometimes, well, most of the time, we can get a function pretty close to represent what our information looks like so that we can make predictions inside and outside of our function, or they call it interpolation or extrapolation. Now, this is just the first go at all this, and if you've already seen some videos on it, I apologize for the repeat. But when you get into statistics, they'll take this idea further and talk to you more about how to better determine with things called the variance and line of best fit and things like that. So just one second here. I Sorry, I had to yell at my kids who are knocking at my door. I don't know if you heard that. I'm yelling at my kids. They're knocking on my door, trying to interrupt the video here. Um, so sorry, I got off track real quick there. But yeah, so these models we're making are just best guesses, but they are functions. Um, and they're our best function we can come up with that is a function that upholds to the rule for every input, there's one output. So this data, we've already talked about, it is not a function. And that's because it breaks the rule of a function. For every input, there's a couple outputs. And that happens, at 20, there's two outputs of 18 and 21. For the fertilizer, when the outputs are 30, or excuse me, inputs are 30, I still have two different outputs here and here, and so forth. So hopefully you get the idea. And I've talked long enough. Let's actually go ahead. We know we want a quadratic model now. And let's go ahead and try to figure out the equation for the quadratic model. Now, I've already gone ahead and let me see if I can switch over here. For time's sake, gone ahead and put in all my information. Now notice this is just the y equals. This is where you graph functions. And if I were going to quit out, that's my home screen. But if you don't remember to do a quadratic function or a quadratic regression rather, hit the stat button. And this is on a TI-84 and 83s and 85s. They'll all be very similar. Some have a little bit of variations in it. So if you have a different model, you might have to do a couple different keystrokes. And then I want to edit in your data. So go ahead, hit the enter button, and you might have some pre-existing data there. And actually, I've already gone through, again, for time's sake, and entered in my L1 and L2. Be very careful when you're doing L1 and L2, or my X values and my Y values, better yet, input values and output values, because you got to make sure when you're doing this, for every input, you have exactly, let me get out of that column, one output. If you don't, when you try to compute this stuff, you'll blow your function up and it won't work. You'll get an error reading. But for L1 and L2, I'm pretty good. And it's okay, actually, to have some stuff in there for L3. But remember, at any time, if you want to delete some information, you just go to the top, hit the clear button, and then hit enter, and it will delete any old stuff. So if your calculator has old stuff here for L1 and L2, you can go ahead and do that too. But pause the video, make sure you have in these values off of our word problem there. And then when you get everything entered in, come on back and I'll continue. Okay, so if you're back, part C says use your calculator to find the quadratic regression equation. Now, we've done this a couple times, so hopefully you can follow along. And as I go, remember, now I've edited in everything. And now what you need to do is calculate it. So go back to the stat feature. And instead of editing, I want to calculate. And in this case, we've already decided that we wanted to do a quadratic regression. So go ahead and hit enter. And from future videos, you've already seen that list 1 is there for X, list 2 is there for Y, or the inputs and outputs. And I haven't really done this for you yet, but you also have the option on this calculator. I can show you how to do it in a different video, or maybe you can ask me during math lab or whatnot if your calculator doesn't have this format, how to do what I'm going to show you here. So if you don't have something that looks like this, please ask me later, or I can show you now too. But if you wanted to graph your function that you end up with so that you don't have to copy it into your Y function and graph it later, there's kind of a cool way to do it. And I'm bringing this up and I haven't even practiced it in quite some time. But so watch what happens. I believe if you hit this vars button, and then if you go to Y vars, and then you're already on this function button, you can rewind the video if you need to as well. So hit enter. It's going to say whatever function you get, they're going to throw it into your Y function over here. So I'm programming my calculator, so go ahead and hit enter. And again, if that went too fast, you can go ahead and back out of it and redo the video, or maybe I'll do it one more time for you. If your calculator on the 84 does not look like this, I might as well do it, and you just have a blank screen. When you go through and hit stat, calculate, if you go ahead and do that, I'm sorry here because I'm in between modalities. So let's pretend your calculator doesn't look like this, but you're still going to go to Stat, Calculate, go down to Quadratic or Quad Reg, however you want to call it, and hit Enter, and you'll still get this. Okay, and on your calculator, what you'll probably see is something on a blank screen on your home screen that just said Quad Reg. And I mentioned this in another video too. Now, for your calculator, you're going to have to find L1 and L2 and enter those in accordingly. So you're going to do L1, comma, L2, and I'm running out of room, but you also want to hit comma, and remember your comma is right. Oh, I can't even see on my screen here. Your comma is right here. So L1, comma, L2, and then you're going to do this trick to get that Y1 function here. Sorry, it's a little sloppy, but that's what you're going to want to do, and it will in effect do the same thing. So one more time, to get that Y1, let me back out of this. You're going to hit, let's see if I can control my calculator again, vars, y vars, enter, and then because you want to throw it into the y1 value, hit enter. You got to make sure there's nothing there to begin with. And then you'll be all set. So either way you want to do it, I'm going to delete this stuff so you can see it clear here. But either way you want to do it, this way or this way, you should be okay. Okay? Let's back out of this share version. Go ahead and hit calculate and see what you come up with. Now notice you now have a quadratic function, and you can put this in your notes too. I'll stay on this screen while you write them in on your notes if you're playing along here. But if I were going to write that in, you now have a function that says y equals negative 0.0. Now watch, be careful. If I start rounding, your answers will differ from one another. X squared, that's my A term. My B term, which is here, is going to be plus 1.1227x. And then my C term, which is here, 5, 7. And you can choose to round, but again, your individual answers will differ from one another depending on if you round here. Notice how I rounded to the fourth decimal or third decimal place there. Always better to do as many as you can. And in this case, remember I did that whole, I put that weird y1 in there to force my calculator to go ahead and graph it. So there's your function. You can write that down somewhere, and I'm going to do that too as I'm looking at my desk here and scrambling to write that down. Negative 0.02. And again, our answers will be different if you don't round exactly the same way I'm doing. Probably better practice to do 3 or 4 decimal places, but I'm doing it exactly as you see on the screen right now. So there's my quadratic function, okay? And make sure I have it all written down. Let's clear all these drawings. And so you can put that function in for part C, if you like. And then for part D, well, actually, before we go there, check this out. This is the whole reason I had you plug it in. For your function then, when you hit y equals, notice the calculator has then put a bunch of decimal places, and I can scroll to the right if you want, but it's done all the work for me and plugged in a very, very pretty accurate graph as far as this regression equation. Remember, excuse me, the regression equation is not perfect. And if I wanted to graph it, you could, but based on your previous zoom settings or your window settings, I'm not sure, you're going to get a good picture. Now this picture's terrible. So let's go ahead and practice. Notice I'm doing more than the problems are asking on purpose, because when you get this on a midterm or a final, you're going to have to be able to do all this. So please play along here and don't just think that, oh, I don't need that. You're going to need it. Now, in your original amount of data, if you're looking at your notes, I think it started at 0 and went to 40 for the inputs. So I'm going to start back at negative 10 and go higher than 40. I don't, maybe 60. See what I'm doing? Giving myself a little cushion on both sides, again, to try to let my picture get framed in the center of the screen. And for the y values for bushels, I think we had 4 to 17. And again, let's go ahead. I'll just put negative 10. That's fine. to 17, we'll pick 30. And again, if I'm only going between negative 10 and 30, I can count by twos. This is just my best guess. It is my best guess off of our original problem, off of these values. Notice from 0 to 40 and from 4 to 17. It does not have, you don't have to have those values. Your correct viewing window will be the window that allows you to complete your task so that you can do it. So please be patient. It's a lot of times it takes a lot of attempts. Now once I'm back here, let's see if I can go ahead and graph it. That's not a bad graph. Could be a little longer, right? So, okay, here's my window. And I'm making my x value 100. See how that works. A little bit better, right? So that's pretty much it when you're graphing a regression equation for a quadratic model through data that might not represent a perfect function. You had the equation, which is here, or you can scroll back to the original part where I wrote down your regression function because I don't even know if it'll still be there. Let's see. It won't be there again. But watch how fast you can go. You can start just going really quickly. Stat, calculate, quadratic regression, and you'll know everything's in there and calculate and hit enter and it'll pop back up for you. Okay? Now, until you change the inputs and outputs, you'll always have that data. So make sure if you're ever trying to find something else um, to put in some new values. Now, for part D, as I'm swapping around here, they're asking to find the vertex. The vertex in this problem, remember the x value can be, or actually is just opposite of b over 2a, because that's an axis of symmetry. Remember, x equals opposite of b over 2a. And the function, or the y value, when I plug that in, that's all this means. It used to scare me. But you're looking for an x value and a y value. X value, again, meaning um, the amount of fertilizer used, and that's going to be the amount of bushels yielded. And if you do this, and you can help me out, I'll do the first x, and for time's sake, I'm going to cheat and do the other one later. But I had a function, of, if I remember correctly, negative 0.02x squared plus 1.227x plus 3.576. And that's really what you wanted to put here. And then this vertex, right, is what I'm going to be solving for here. So I'm putting the answers in the wrong spot, but hopefully you get the gist. And if I use the opposite of b, so that's negative 1.227 over 2 times negative 0.02. Now let's go ahead and calculate that. And what I tend to do, because this value 2 times this, I want my calculator to input the right values, I'll do the bottom first. So 2 times point, and also because I know this is a negative and this is a negative, I'm not going to use any negatives because those two will make it positive. So on the bottom, you're going to have 2 times 0.02, I believe. So that'll be 0.04. And on top, we can carry that over. And if you take the positive value, right, because this is now positive. So 1.277 divided by 0.04 is going to give me 31.925. Now, important to note, that's this value here. Okay, so when you use, that amount, notice it's right in here. 31.925 is right. Oh, your maximum value is going to be right in there somewhere. So my y value should be between 21 and 22. And you could do, again, if you wanted to, pause the video, take this value here and plug it in for x here in the parentheses and x here. And if you want to try to do that, go ahead and pause the video. We'll see if you come up with the same answer I do. All right. But what I'm going to also do, just to practice bouncing modalities here, remember we're doing this a variety of ways, I'm going to go back to the calculator. And remember, we graphed it, and the reason I graphed it was so that I don't have to do all those calculations. If I want to do the vertex, second, calculate, let's do the maximum, which in this case is the vertex. Remember again, I need a left bound and a right bound, so I have to go to the left of where I'm interested in. Hit enter, go to the right of where I'm interested in, and hit enter again. Enter one more time, and there's my maximum and minimum. Now notice this is using the function with all this much more accuracy. So their maximum is at 30.36. So let me write that down. 30.36, 20.62. Okay, so I wrote those two. Now those are the values that are at the bottom of the screen there. And if I bounce over, and it's okay. Now notice their value is 30.36 on the calculator. Let me see if I put this. So on the calculator, and theirs is more accurate, 30.36. And notice if I were to round, this would be rounding up to 31. And the value for the vertex was 20.62, right? So that would be the vertex. That's more accurate than mine. And be careful when you plug this in, if you just participated, your Y value will be a little different from this one too. And it's okay because, again, this equation here is just whatever you round it off. So there'll be a little give one way or the other. The calculator's function is probably a little bit better than mine. And the Y value, 20.62, notice is just a little bit below what you would think here. Okay, so what does that mean? So at that vertex, that's going to give you the amount of fertilizer for the maximum yield. If you were going to use a sentence, you could say 30.36 pounds of fertilizer will yield, I don't know, 20.62 bushels. That's how you would communicate it in English. And notice we're talking about fertilizer and bushels, but this applies, again, if you're working for Google or if you're working for a textile or a clothes shop. You know, it doesn't matter if you're working at the Gap and you want to make or maximize your profits, or Old Navy, or not Home, or Home Depot for that matter. So the other question for part E, which we're going to get here and then we'll conclude this video, is saying, does the vertex you found here, this value here, over predict or under predict the real maximum yield? Now the real at 30.36, you should see is right in here, huh? It's right above. And my prediction was 20.62, and you'll see this is under these two values here, doesn't it? So in real life, my data showed that I was going to get 20 or 22, 21 bushels, where my prediction was a little off, again, because the round off error. Again, this is the big moral of the story. This data is not perfectly quadratic. It's not perfect, but again, it's our best guess. Our function in this case would look something like this, and we showed that in our graph, where if you try to, right here, that's not a very good representation. In other words, exponential and linear don't work in this case. Okay, so hopefully that helps. If you need more practice, go to YouTube and type in quadratic regression, and there'll be some more problems for you there. But good job and good luck.